Welcome back. This is the third lesson about trees, and in this lesson we'll implement a tree in a 2D array. This is not the only way to make a tree work in programming, but it does come up in the exam. So in this lesson we'll start by visualizing a tree as a shape made of circles and lines, but then we'll look how we can implement the tree by storing data and pointers in an array. By the way, students sometimes say to me, well, what if you added an extra node here? Let's say, look at the tree on the left, the 55 or the 25. If you added new nodes on there, it would crash into the rest of the tree. And that's absolutely true. And that is a limitation of setting out a tree like this, that it can get quite messy. Don't worry, in the exam, any examples will be set out in a way that doesn't cause that problem. But it is one of the reasons why showing a tree in this way isn't the only correct way to look at a tree. And there are advantages to setting a tree out using a different method, which we're going to look at now. Now, what if we wanted to store that information in a 2D array? You can see it's quite similar to the way that we stored a linked list, but instead of a pointer, we've got two pointers, and we typically call them left and right because they go off to the left and right of the node. Of course, do remember that they don't really go left and right, it's just the way that we visualize it. Now, suppose we wanted to add a single item to that array. That would be the root node, the first item in the tree. So this time I've given it the data value, the letter F, and obviously the pointers are null at the moment. There's no more data in the tree. But as we add data, the array will start to fill up. Perhaps it will look like this. So we can see that the root node has got two pointers, one pointing to address 1 and the other pointing to address 2. And C is at address 1 but hasn't got any pointers. P is at address 2. It's got a pointer to J. And other than that, there are no other pointers. Now, you can see my heading there, make this tree. So this is what I want you to do. There will be a bigger activity in a minute. Stop the video and try and draw that tree. And in a minute, I'll bring up my answer. So pause the video, get a bit of paper and pen, doesn't have to be neat. Draw the tree that is represented by that information in that array. And then when you're ready, click to move on. So this is the answer. F is the root node. It's got C on the left and P on the right, and P has got J on the left. So that is a tree, and the same tree, those on what you see on the screen there, that's two different ways of showing exactly the same thing. One is a visualization and the other is set out in an array. So supposing we wanted to add a new node to the tree. There's an example here, the letter A added as a new node to the left of C. Now, how would we adapt the data in the 2D array to represent that new node? See if you can do it now, and I'll show you in a sec. So the first thing we'd have to do is to create the node in an empty space. It's holding the data A and it's got no pointers off it. Now we've got to add a pointer to node C to point to this new location. And that's it. Now A has been added to the array and to the tree. Similarly, if we need to delete a node, let's say we need to delete J from the tree, all we do is we remove the pointer that pointed to it. So that's to the left of node P. Get rid of that and replace it with none. And now J no longer is added to the tree. It's still there in the array, but it's not part of the tree. So this short lesson has shown you how we can draw a tree as a diagram, like the diagram shown on this page, or we can represent exactly the same tree in a table that represents a 2D array with columns for the left and right pointers. We've just turned a 2D array into a visualization of a tree structure. Here's a tree structure. From this, I want you to make the same tree as a 2D array. Do as much of it as you can, and if you get it finished, then add further amendments to add a node with J to the bottom right and delete the node that has C in it. And then you can upload the file with your answers. You could do this with paper and pen, scan it in, or you could create a table in Word and type the data. I'm going to circulate a link where you can upload your results so that I can mark it. This is a bigger piece of work, shouldn't take you too long, but I'm going to give you a day to get that done before we continue with the rest of what we're learning about trees. Bye for now.